Good morning or afternoon. Today we are looking at day 2 of complex numbers in polar form, and there's going to be a couple other things we're going to do. So the other day we multiplied and divided complex numbers using polar form. Today we're going to do powers, and we're also going to do roots. So the first one is powers. Powers is not very bad. The theorem, it's called de Moivre's theorem. He's some dead guy, okay? But they named a theorem after him. Given a polar number, so it's a complex number in polar form, so you get your r cosine theta plus I sine theta that we learned the other day. If you take this number to the nth power, okay, so it could be the third power, the fifth power, the 10th power, whatever. What you're going to do is you're going to take r to that power, and then you're going to take theta and you're going to multiply it times that power. What this really is, it's the multiplication formula we learned the other day, except you're multiplying this r times itself a certain number of times, and you're adding theta to itself a certain number of times, and so the formula looks like this, okay? So, given a number in polar form, so 2 cosine 20 times I plus I sine 20 to the third power, all you do is take 2 to the third power, so 2 times 2 times 2, that's 8. You take the cosine of 20, you take the 20, and you multiply it by that power. So take 20 times 3. So cosine of 60 plus I sine of 60, and that's it. So instead of taking a number and multiplying it times itself and foiling that out and getting an answer, and then taking that times itself, foiling that out and getting an answer, you can just use this formula which says take that to the power, take that times the power, and that's your answer. Now, unfortunately, that's not our answer, because for this, it says to write our answers in standard form. Okay, so this is polar form, so that's where we just have to take this and we have to simplify it. Okay, so again, I've got my handy chart right here. The cosine of 60 is 1/2. The sine of 60 is radical 3 over 2. Put the I on the end, and then distribute the 8. 8 times 1/2 is going to be 4. 8 times radical 3 over 2. Again, the 2 and the 8 are going to reduce and give me 4 radical 3i, which you will also see, here's the third place I can put an I, is 4i radical 3. I do not care. I think this answer is fine. We have a habit of not putting variables, or if you think of I as a variable, after the radical, because if you extend your radical, like if you are kind of sloppy and you extend it, sometimes it's kind of hard to tell, is that under the radical, is it not under the radical? And so then we put it out in front of the radical between the number and do it that way, so there's no question. Okay, so take a look at example B. Go ahead and do this. Take this number to the 4th power and then rewrite it in standard form as your final answer. I'm going to pause it as well, please. All right, and here is my answer. So I took 3 to the 4th power. So 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's where I got the 81. I then took 30 times 4. That's 120. Then I rewrote this in standard form. Now, 120 is in quadrant 2. So it has a reference angle of 60, but the cosine of that is going to be negative. The sine is going to be positive. And then I distributed the 81 in. Wasn't a whole lot I could do with an 81 and a 2, so I just left it as negative 81 over 2. And then plus 81 radical 3 over 2, and then I. Okay, so that's de Moivre's theorem. It's weird. It's French or something. You say the R actually before the V. De Moivre doesn't look like that. It's like Brett Favre. So anyway, instead of Favre. All right. And then the last thing we're going to do is we're going to find roots. Okay, so it'd be the opposite of what we just did. So this one, there's a bit of a catch, a bit of something different about this. when you find roots, okay, like square roots, okay, what's the square root of 16? Well, there's actually two square roots of 16. There's 4 and there's -4. Okay, all numbers have 2 square roots. But what you may not know is that all numbers have 3 cube roots and 4 fourth roots, and so on and so on and so on. Now, like the cube root of 8 is 2, right? There's also 2 other that you don't know because they're complex numbers, okay? And if you take these complex numbers and you cube them, you will get 8 as an answer, even though they're going to be kind of weird looking numbers. So, and that's actually the first one I'm going to do, and I'm going to show you 8 and what the cube roots of 8 are. So first off, here's what the formula is. The formula says to find the cube root, so to find the nth root. Okay, so it could be whatever root. It could be the cube root, the fourth root, the fifth root. To find the nth root of a number, you find the nth root of r. So it's the same thing we just did. Instead of taking r to a power, we're going to take the root of that r. And then we're also going to take our theta and we're going to divide it by n. Okay, it's the same thing we just did. On the last example, we multiplied our theta by a number, and this time we're going to divide by it. So these two parts are just like what we did, except they're the reverse. This is the root, and this is division instead of a power and multiplication. So that should not be anything tricky. This is the catch. Okay, now you'll notice I'm doing all these in degrees, so for these problems we can keep things in degrees because of the formula here. If you're finding cube roots, there are 3 cube roots. Those cube roots are going to be evenly spaced throughout the plane. So if there's 360 degrees, you divide that by 3, you'll get 120, and that's where your roots are. So if you're looking at numbers in polar form, if there's one at 0, there'll be one at 120, and there'll be one at 240. They're going to be evenly spaced out. And down here on these answers, we're actually going to graph them so you can kind of see that. We're going to plot the points so that you can kind of see that those are evenly spaced. If you were finding fourth roots, there are 4 answers. And those answers are all going to be 90 degrees from each other. Take 360 divided by 4, and that's the spacing between the numbers in polar form. Okay? So let me show you what this looks like. Now, find the complex cube root of 8. Okay, so that's just the number 8. We need these to be in polar form. Okay, so like this one over here, I'm going to have to rewrite that in polar form for this to work. But the number 8 in polar form would just be 8 plus 0 I. That's our starting. There is no imaginary part. Okay, so there's just a real part. So our first solution, there's going to be 3 of them, okay? We usually call K0. This is our initial solution, okay? This is our first solution. And that's going to be the cube root. Oh, excuse me. Let me rewrite this. So this is a complex number, and then I need to write this in polar form real quick. Well, that's not going to be very hard. That's 8 cosine of 0 plus I sine of 0. Okay, so now I got my polar form. So we're going to take we're finding the cube roots of 8. So we're going to take the cube root of 8, so that's 2. And then we are going to take our angle and divide it by 3. Okay, we're finding cube roots, so we're going to take our angle divided by 3. Well, in this case, it's just 0. Okay, so 0 divided by 3 is going to stay 0. So it'll be the cosine of 0 plus I sine of 0. So that's our first answer. Now, that would just be the number 2, right? So we have an angle of 0. We go out to 1, 2. That's that solution. Okay? But there's 2 more. There's a K1 and there's a K2. They both have the same R value. It's still going to be 2 times something and 2 times something. The only thing is where they're located. So we're finding cube roots. So there's 3 of them. So if you take 360 and divide it by 3, you get 120. This is the magic number we're going to add to find our other answers. So we're going to add 120 to this angle, and we're going to get cosine of 120 plus I sine of 120. Then we're going to add 120 to that answer, and we're going to get the cosine of 240 plus I sine of 240. And those are our other two solutions. So these are the three cube roots of 8. So one of them, so where's 120? Here's 120. Out 2 towards 120. That's another solution. And 240. 1, 2. And you'll get the, oops, I got to count right here. I'm going to make it big. Okay, so you get these three solutions. Yeah, connect them. You can see that they're all evenly spaced. They're 120 degrees apart from each other. And if you found, so like this number right here, what's the cosine of 120? Cosine of 120 is negative 1/2. And 2 times negative 1/2. Now, you don't have to do this. The directions don't tell you to do this. Okay, 2 times is negative 1. And then the sine of 120 is radical 3 over 2, so that's radical 3. If you take that I, if you take that complex number and you cube it, okay, so you take negative 1 plus radical 3i times negative 1 plus radical 3i, you multiply that out, and then you do it again, you will get 2 or 8 as an answer. Okay, that is a cube root of 8. If you cube that, you'll get 8 as an answer. It may be easier to do right here in polar form. You take 2, remember, how do you take this to the third power? You take that to the third power. You take that times 3, but that'd be 360. And sure enough, you'll get 8. These will be, you'll get one of them will be 0, one of them will be 1, and you'll get 8 as an answer when you distribute that in. Okay, so this is how we do a cube root. Look at the next one. It says find the 5th roots. So there's going to be 5 of them. Okay, where are they? How are they spaced out? Well, if you go off to the side, and off, this is what something I do first. I just take 360 divided by 5. So put that in your calculator, and you'll get 72. So all my answers are going to be 72 degrees apart from each other. So I'm going to find my first answer, and then I'm just going to add 72, add 72, add 72, add 72, until I have the number of answers that I want. Okay? The problem with this one is I gave it to you in, this is standard form, so we need to turn that into rectangular form. So there's a little bit of work we got to do. So remember, r equals the square root, because I need my r and my theta. Square root of negative 1 squared plus radical 3 squared. That's going to be 1 plus 3, so that's 2. Theta is the inverse tangent, be careful on this one, the inverse tangent of radical 3 over negative 1, so that's negative radical 3, plus 180. Okay, so this is one of those that's over in quadrant, if you go left and up, it's in quadrant 2, and we're not going to get an answer in quadrant 2. The inverse tangent, remember we're using degrees, inverse tangent of negative radical 3 would be negative 60. And if I take negative 60 and add 180, I'm going to have positive 120. All right, so there's my r and there's my theta. Okay, so this number is r, oops, it's 2, so our number z is 2 cosine of 120 plus I sine of 120. And now I can find the 5th root. So I'm going to take the 5th root of 2. This is my first answer. It's our little K0 or whatever. Okay, or Z0. Should use the letters. Sorry. Should use the same numbers that I've got up there. Alright, so Z of 0. We're going to take the 5th root of 2. We are just going to leave that as the 5th root of 2. We're going to take 120 and divide it by 5. Okay, so grab your calculator. Dang it. 24. So cosine of 24 plus I sine of 24. Okay, so that's our first answer. Okay, so the fifth root of 2 cosine 24 plus I sine 24. Now, you are going to take that angle, and you're just going to keep adding 72 to that angle until we have our 5 solutions. Okay, so that's Z0. We need 1, 2, 3, and 4. Okay, so we started with 0, so that's our fifth answer. The r's always stay the same. They're always the same distance, like on this one. So this is still the fifth root of 2. This is still the fifth root of 2. Fifth root of 2. And then we are just going to take 24. See it better here. Plus 72. And we get 96. So cosine of 96 plus I sine of 96 plus 72. 168. Cosine of 168 plus I sine of 168 plus 72. 240. Cosine of 240 plus I sine of 240 plus 72. 312. Cosine of 312 plus I sine of 312. Okay? And those are our 5 solutions. So again, the fifth root, let's see if I can remember how to write this. Fifth root of 2. I think you put 5, then hit the root button. Yeah, it's like 1.1. So we have 5 solutions. They're all 1.1. But one's at 24 degrees, so this is 1530, so there's an answer here. 96 degrees, there's an answer here. 168, well, this is 180, this would be 165, so just past that. There's an answer here. 240, there's an answer here. And then at 312, there's an answer. Where's 300? So 360, 330. So there's an answer here. Okay, so there's our 5 solutions that are all evenly spaced out around the circle. You can kind of see it a little bit there. Okay, and again, if you take any of these and take them to the 5th power, well, if you take this to the 5th power, you're going to get 2. If you take these to the times 5, right? That's what happens when you multiply. You're going to get an angle that when you take the cosine and the sine and you distribute the 2 in, sure enough, you're going to get this -1 plus radical 3 every single time. Okay? So take a look. These take a little bit of practice. Okay? So if you need to rewatch this, rewatch it a lot while you're doing your own example. So do your own example and then step by step try to do what I just did. Okay?